This is section 2.2, graphs of linear functions. So this is going to be a review of Algebra 1. So to graph linear functions, you can either make a table, or you can graph the y-intercept and use the slope. I prefer to graph the y-intercept and then use the slope, especially when given in slope-intercept form. So f of x equals negative 2/3 x plus 5. Remember, 5 is your y-intercept, and negative 2/3 is your slope. So to graph it, I'm going to go over here. We start at 5 on the y-axis, so 1, 2, 3, 4, 5. And then we have a slope of negative 2/3. That means we can either go down 2 and to the right 3, or we can go up 2 and to the left 3. Double check yourself. Remember, if it's a negative slope, it should be going downhill from left to right, which it is, and then just connect the dots. You could also make a table and plug in values. 0 is always a good one, so 0 and 5. I like to have, since there's a fraction, I like to cancel things out, so I like to put negative 3 and 3. So negative 2/3 times negative 3 is positive 2 plus 5 is 7, which we have over here anyway in the graph. And then negative 2/3 times 3 is negative 2 plus 5 is 3. And then we could just graph those points. So let's match each equation of the linear functions with one of the lines. So f of x equals 2x plus 3. So I know the y-intercept is 3, which rules out the green line, line 2. And then our slope is 2. So that's going to be steeper, and it's going to be positive. So it looks like line number 1. G of x is 2x minus 3. So our y-intercept is negative 3, which only leaves us with line 2. H of x is negative 2x plus 3, so it has a y-intercept of 3 and a negative slope. That leaves us with number 4. And j of x equals 1/2 x plus 3, so y-intercept of 3. It's a positive slope, but it's a fraction, so it's going to be pretty flat, which leaves us with line number 3. Find the x and y intercepts for the function. So our y-intercept is pretty easy to find here. It's at 0, negative 6, because we can just look at it in slope-intercept form. To find the x-intercept, what we're going to do is we are going to, remember an x-intercept is where y is 0, so we're going to plug in 0 for f of x. So 3x minus 6, and just solve for x. So 2 is equal to x, so our x-intercept is at the point 2, 0. If you want to double check yourself, go ahead and use a graphing calculator to double check that you're correct. Vertical and horizontal lines. So vertical lines are always going to be in the form of x equals some number. Horizontal lines are going to be y equals some number. So for this line over here, for example, this is the line x equals 7. Parallel lines are always going to have the same slope, and perpendicular lines are going to have negative reciprocal slopes. So for example, if your first slope is going to be, let's say, 2/5, your perpendicular slope, you flip the fraction and change the sign out front. So let's write the equation of the parallel line to f of x equals 3x plus 6 through the point 3, 0. Well, if it's parallel to that line, it has the same slope, so we know that m equals 3. and we know it goes through the point 3, 0, so I'm going to go to point slope form. So y minus 0 equals 3 times x minus 3. Y minus 0 is just y, so 3x minus 9. So that's our parallel line. For the perpendicular line, we're going to take the negative reciprocal for the slope, and that's going to be negative 1/3, still going through the point 3, 0. So y minus 0 equals negative 1/3 x minus 3. So y equals negative 1/3 x plus 1. So these two lines both go through the point 3, 0, and they are perpendicular. And the last thing from this lesson, systems of linear equations, you're looking for where the equations are the same or where they intersect. So you can graph them and look for the intersection point. You also can go back to Algebra 1 and think about, we did substitution and we did elimination. Those methods will work as well.